So today we are going to have something related to the chapter that we started on Monday, which is chapter 5. So we talked about the heat, we talked about the law of conservation, and we also calculated the energy as a heat, right? And today we're going to highlight and also approach the same exact topic. So hopefully by the end of today you will have more comprehension about the topic that we covered so far. So we are going to have a strong acid and strong base. Now the strong acid and strong base require your attention. You have to wear your goggles. You have to be very careful because they are very strong. As you can see, there are 2 molarity of hydrochloric acid and 2 molarity of the base. So what we are going to do first, we are going to, if you read the procedure step by step will be very, very helpful to you. But I'm going to give you a summary of what we're going to do today. So when we are going to mix the sodium hydroxide with hydrochloric acid, what are we going to end up? Are we going to keep them acid and base? So what is going to be? Like you see, there's a salt and water and also energy. Energy as a heat. So you will be able to feel the heat of that. Maybe or maybe not. Because we are going to use the styrofoam. And this is basically a mimic of the calorimeter. When you have the styrofoam, it is going to be insulated from the surrounding. So loss of the heat is not going to be as easy as when you're going to have a, glass beaker, for instance. Okay? And that's the whole entire purpose behind having a styrofoam. So we are going to measure 50 milliliter of 2 molarity hydrochloric acid in a graduated cylinder. And the cylinders are going to be given to you. You see here, it's like you need only 50. You're going to have 2. Each group will have 2 cylinders. One is going to be marked for the acid, the other one will be marked for the base, okay? Don't mix them when you are going to measure it. All right, we're going to keep them both, all right? One is going to be with the acid, will be poured into the styrofoam, and the other one, which is the base, will be poured into the beaker, okay? You have the thermometer for both of them, all right? And then you are going to start monitoring with the timer for 5 minutes. I want you to go into your data sheet, please. Page number 55. If you look at page 55, you can see there is a column about the time in per minute. You're also going to see, determination of the temperature for the base and for the acid, separated before we mix them. So do you see that? For how many minutes? You're going to have them separated. You tell me in the data. 5 minutes, okay? So this is the 5 minutes in the diagram that we are going to sketch, okay? For 5 minutes, you are going to have the time and the temperature for both separated acids and base, okay? The beaker, you're going to measure the temperature in the beaker, and you're going to measure the temperature of the acid in the styrofoam. Okay, for 5 minutes. 5 minutes, every how long? Every how long? What's the interval? 30 seconds. 30 seconds. Every 30-second interval, okay? After you finish 5 minutes, then you are going to have at 5.5, because we are going to mix them. Now we are going to get the sodium hydroxide. We pour it into the acid, cap it, and then we start monitoring. We start monitoring for 15 minutes. Now, after you mix them, you are going to start monitoring for 15 minutes. The interval is 1 minute, every 1 minute, okay? And then if you look at the data sheet, you're going to see another more reading until 20 minutes. You have it here in page number 55. Is everybody clear about it? Yes. So this is what we are going to do. we're going to mix the acid and base. So now we are going to have it, you're going to see the temperature will shoot up because those are exothermic reaction, right? So immediately after probably room temperature, about in the 20s, then now all of a sudden you have like 35 or 36. When you are going, and then you're going to monitor, and then what's going to happen? The temperature goes up and then start going back down gradually, okay? Because now we no longer have the acid or the base. We have the salt and the water, okay? So there is no more acid, no more base, right? And the aqueous solution here is water and salt, which is going to be neither acidic nor basic. Is that clear? Okay. So when after you are going to finish and you have those numbers, you are going to plot them on this diagram. So the x-axis is going to be the time per minute, and the y-axis is going to be the temperature in degrees Celsius, okay? Now, between 0, this is the 0 over here, okay? 0 time when you first started until 5 minutes, okay? So what we're going to do, we're going to measure them separately, and you're going to see there is a section in the following page. It says, take the average, okay? So then, after that, you're going to mark that. This is the initial temperature. It is the initial temperature before they got mixed up. After you mix them, you're going to see how it is going to be elevated, the temperature. Mark that, and then you're going to see it is going to go down, all right? Then with the ruler, you are going to have a line goes all the way into, and then intersect with this. This line is said line of mixture, the line of mixture, okay? At that point, we mix the two, right? Chemicals together. So when you're going to draw the intersect, you're going to have a point here. This is supposedly the highest temperature, and this is the final temperature. So now, we actually marked the initial temperature, we marked the final temperature. That's what we need for the delta T. Okay, and we know delta T is equal T final minus T initial. We also need to calculate the heat that was produced out of this exothermic reaction. How are we going to calculate it? According to what? Q is equal specific heat mass times delta T. So the specific heat of the mixture was given to you. It's already there in the front page. And also in the calculation, all right? Now, how are we going to find the mass? The mass from the volume. And how is that? Okay, I have volume, I need mass. Yes? Density, thank you. So, multiplying the volume by density will give you the mass. Do you see that? Now, why did I say total volume? What do we mean by total volume?
It's a solution.
The two chemicals. So it is going to be 50 plus 51, it is going to be 101, right? And this is going to be the volume multiplied by the density, which is given to you, right? 0.98 or something, or 3 point something, yes.
You gotta convert it to liters though, right?
Sorry?
You have to convert it to liters.
Oh, sure, definitely. Thank you, Kayla, that's exactly right. So we know, do we have to convert it here?
No, I was asking because usually we put last.
No. That's not molarity. Maybe in molarity we will. Because when we have molarity is equal mole per liter, but for density milliliter. So we'll keep it as a milliliter, okay? What we need to calculate the mass. You have all the like you know the other parameter. You have the density, you have the specific heat capacity now. Multiply, just use this equation, exactly the same. Okay? And then that means mass times, and this is exactly what we need. We have the specific heat given to us. We have the mass, we're gonna find it from the density times volume that we use, which is 101. And multiply by delta T because we are going to measure the final minus initial, okay? Now we find the heat as in, like, the energy as a heat in joule. In joule. Okay. Now, if you remember, delta H is the enthalpy of the heat. It is kilojoules per mole. Okay? That's what we're going to need next. Now, the mole of, look here, HCl. So when it says the number of moles of HCl, that means you are going to use the 50 milliliter divided by 1,000, get it into the liter, stick it into what?
Concentration.
That's what we need. Okay? We have the molar. Do we have the molarity of HCl?
Yes.
What is it?
2.
It's 2 mole per liter. Multiplied by 0.05, right? That will give you the number of moles of the hydrochloric acid. Stick it in here, okay? Mole of hydrochloric acid. You calculated the joule. Divide this also value by 1,000 because we need it in kilojoule. Got it? It has to be kilojoule because this is kilojoule per mole. So after you calculate the Q, which is in joule, and why is it in joule, not kilojoule? Anybody know? Why didn't I put, okay,
Because this was
kilojoule? What is the unit of the specific heat?
is joule per gram.
It's joule per gram degree Celsius. That's, and we're gonna cancel out because this is degree Celsius, right? And this is here the mass in grams, so it will be canceled with these, and you end up having it in joule, okay? Now, after you calculate the joule divided by 1,000, get it in kilojoule, we are going to calculate number of moles from the molarity of the acid and the volume of the acid also there. And now, at the end, this is what we need. You're gonna have 2 attempts, and if you look at the data in page number 56, you're going to try it twice and then take the average at the end. It's only one value at the end. So this is what we're going to do today, okay? Any questions? Do you have any questions? All right, so now I want you to come and help yourself. So we do clamp it over here, okay? And then you can always move back and forth, all right, like this. Be careful, you don't want to break it. It has to be very careful because otherwise you're going to break the thermometer in your hand. And you don't want to do that. So I'm going to clamp it like, here. And this is how you are going to have that. Going to bring it down. If you look at the my own drawing, you see the bottom of your thermometer should not touch the bottom of your styrofoam, okay? And we do have to have the stirring rod. You can always do that later when we mix it, okay? So anyway, this is how you're going to measure your acid, okay? And then you are measuring your NaOH, in other words, the base on the same time. By the way, this is what happened the previous lab. They did it on a separate, in other words, they measured 5 times here, and then after this 5 times done, they measure the other 5 for the first 5 for the acids and base. You have to do it exactly the same concurrently. In other words, because we have a group of 4 or 3, so one will monitor the acid, the other one should monitor the base, okay? Don't, like all of you, on this one and then leave the other one. So then you will be able to finish on time, okay? And then after that, you're gonna bring the base, pour it into the acid, cap it, okay? And then you start monitoring for another 15 minutes. So this is the apparatus that you need to have. Keep the acid here, okay? Then you're gonna pour the base into it. Make sure that you have the rubber stopper here because you don't want to squeeze on the thermometer and break it. We don't want to do that. So that's what we're going to do today, okay? Is there any question? You have the procedure. Read the procedure. It is actually giving it to you step by step. Yes, Kate?
So when we put the thing in, we have to cap it and leave the thermometer.
Yes.
How am I supposed to do that?
How
Yeah, but
to read it?
off and then, no, like, how do I put the lid on with the thermometer?
Oh, you can always take it up, pour it, and put it back again. Okay? Very good question. All right? So is everybody okay?
I do.
All right? Yes.
So the thermometer, when we're measuring the base, that can sit up above everything, right? We don't have to hold it.
You can always leave it there, yes.
Yeah, we can
The
do that,
bar.
right.
Yes. Thank you for your question. Okay, I think we are okay to go. And then you can always ask me if you have any question, okay? Thank you.